Welcome to today's lecture on application and selection of accumulators. This is part 1. Today we shall learn very fundamentals of accumulators. Now, in case of hydraulic circuits where a large flow rate is required for a short period, alternating with a low or no flow condition, the use of an accumulator allows smaller pumps and motors to be used, thus reducing both installation and operating cost. So, basically we store the energy when the full energy is not required for the operations, and it is kept in store and utilized when the when more power is required, more pressure is required and flow is required. Now, if we look into this cycle, operation cycle of any system which would require a pump having capacity of Q 2, okay, then what we can do, say initially it needs V 1 and then V 3, then volume V 2 and then V 4 and so on. It goes on like this. This is one cycle, the next cycle is similar. In that case, also we consider V 1 plus V 2 is less than V 3 and V 4. Here V 4 apparently it is 0, and this is the duration of such volume. Then what we can do? We can use a pump of this capacity and an accumulator. Obviously, this period should not be very long, these two periods. Then the fluid which will be stored in the accumulator during this period and this period can be utilized to have V 1 and V 2. Okay. If an oil pneumatic accumulator used, why this is oil and pneumatic accumulator? Because this oil is stored in the accumulator. Accumulator is nothing but some sort of a vessels, small vessel, and within that the oil, in this case oil, we are considering oil or liquid, is stored, whereas some part of this accumulator, or initially accumulator is filled with say air, and then air is compressed inside and oil is stored. Okay. This there might have one separator, that means inside this accumulator there might have another bladder in which the pneumatic or air may be there, or it might be open, that means oil can have direct contact with the air. Anyway, if we consider if an oil pneumatic accumulator is used, it is possible to store oil during the time T 2 minus T 1, sorry, these will be T 1, T 2 etc., not L 1. Say T 2 to T 1 and T 4 to T 3, these are not L T. Okay. As I have already explained, when the requirement is very low or 0, and to reutilize it during this period T 1 and T 3, T 2, when the required flow rate is higher than the pump capacity Q 1. This pump must be selected to have the volumes V 1 plus V 2, which is again less than V 3 plus V 4. So, average capacity is calculated in this way. There are many potential applications including thermoplastic extruders, transfer lines in steel mills, rolling mills, machine tools, hydraulic press, etc. These are only few to mention. By virtue of their design, both piston and diaphragm pumps create pulsation or pressure peaks during operation. This being undesirable and detrimental to both the smooth operations and operational life of the components. This we have learned that if there is a pulsation, there is a ripple, then that is performance wise it is not desired, as well as it will affect the life of the components also. The fitting of a bladder type accumulator adjacent to and downstream of the pump will dampen the pulsation to an acceptable level. We have not yet seen what is a accumulator, but as I told that there will be a vessel usually that is made of steel metal body, and inside there will be bladder. Say for example, inside the bladder there will be air or some gas, and the rest portion will be occupied by the oil. In fact, bladder is initially will remain inflated, and then gradually it will the size of it will reduce and the oil will be stored inside. However, there is also possible that gas and oil they are in contact, the no bladder is used. In any case, the fitting of bladder type accumulator adjacent to downstream of the pump usually dampen. Why usually? It will dampen the pulsation to an acceptable level. Typical application are dosing pumps, pumps with small number of piston, etc. As you have learned earlier, the small pistons is having higher ripple, small number of pistons, and in most of the cases, particularly in cylindrical pistons, you will find that these numbers are odd to reduce the ripple, and maybe very common is 5, 7 and 9. So, 5 will have more ripple, and if we use with that 5 pistons an accumulator in all applications, then it is always better. And dosing pump, you understand, it is some sort of feeding the oil, may not be the main system. Now, improvement in performance can be realized from here. What we have done that as if this oil is being pumped in from here, then without this accumulator we may have ripple like this, and if we use an accumulator, this ripple will reduce. This is an accumulator, this one very schematic diameter, this this very schematic diagram, that how it look like, that we will see later. Now, another applications is shown here. In the case of a sudden power loss, that is pipe or joint failure, pump breakdown, the accumulator can provide sufficient energy to complete an operational cycle or to allow actuators, valves, etc., to reset a safe position, and therefore prevent damage to equipment or product. Now, what it is in this circuit? What we find that there is the pump, this is of course the filter, and this is the reservoir, from where the oil is being pumped through a non-return valve or check valve. Okay, this is very schematic, it might be spring, without spring, and then what we find in that line, an accumulator is fitted. In that accumulator, as you see that this is as if a vessel, inside there will be some gas. Actually this is a gas pre-charged, or sometimes you will find a bladder with a charged gas or air is there. Now, this is a stopcock, because sometimes we may not need to use the accumulator, we can separate it. Now, what we find from here, it is connected, this line, this is a joint junction point, this is not crossing each other, this is junction point. That means, this oil can first of all go through the relief valve, okay. Then it can go to a 2 position valve, this is, or you can say some sort of switch on and off, and then there is 4/2 valve, directional valve, and through which it is going to a cylinder. And then from in the return line, what we find that, say this is head side return line, it can go to the tank, again through this junction point, or else the oil coming over here, this can flow through this flow control valve, and it also can go to the tank. Now, what will be the operations? If we consider these connections, then oil is going to the rod end side of the piston, and oil from this head side is going back to tank. Okay. Now, in any case, if the pressure is increased, then oil will be relieved to the tank. However, when the full amount is not required, in that case this is being stored and it is not being operated. Now, in case of any failure here, then this oil can go this side, and through this is a passage, through this oil will flow to the tank in a controlled manner, and this piston, although it will collapse to its position, but it will go very slowly. Okay. So, in that case this accumulator is helping to prevent the sudden collapse of this cylinder. And if it is connected like this, in that case what we find that this oil is going to the accumulator, of course, within the pressure setting of the relief valve, and this oil, this side oil is going, perhaps this arrow could be in this direction, is going back to the tank. Okay. So, this is just to prevent a system in case it fails. So, this is one application of such accumulator. Now, in a closed hydrostatic circuit, a rise in temperature can cause an increase in pressure due to thermal expansion. Okay. In that case, how this accumulator can help? Then title here it is written as volume compensator, but it will do an accumulator installed in the line will protect the valves, gaskets and pressure gauges, etc. How? Common applications are found in refineries and pipelines, where the temperature variations are there. So, in that case what actually happens, this if there is rise in temperature, there will be volume increase in the oil. So, excess volume will generate a pressure, due to this pressure this oil can be stored in the accumulator, and when temperatures comes down again that will be filled. So, very large pipelines and others where actually may not be hydrostatic transmission, but the oil is being transferred with full volume is filled, in that case such accumulators will be very helpful. So, that is volume compensator. Now, we will think of the pressure compensator. When a constant static pressure is required for a long period, an accumulator is indispensable as it will compensate for pressure loss due to seepage through joints, seals, etc., as well as balancing pressure peak which may occur during the operating cycle. So, this means that we have to first keep in mind that oil is being, when the pump is running, then excess oil is being accumulated in the accumulator. Now, then if there is a loss, suppose the system is stalled, that means a weight is lifted and then it is stalled, then what is happening, there will be leakage and etc. That leakage can be filled by the oil from such accumulator. Now, this is an system, this is apparently some sort of press sort of things, where this is being pressed with a pressure for a, it is not very long time, but this operation is being done for a substantial time. And in that case, what is the system? This is a pump with non-return valve and there is a direct relief valve here. It is after the pump and then the non-return valve, this is the accumulator, and then with this there perhaps is another relief valve is there, and then oil is going like this, and it is being used for pressing this one. This is here written, typical applications are found in closing systems. Closing means in that case is pressing something, closing something, loading platforms, curing presses, machine tools, lubrication system, etc. In that case, this accumulator, whenever the excess flow and pressure will be required, that will help. Now, for counterbalancing, earlier we have learned that counterbalancing systems can be designed using the pressure control valves. However, to some extent, if we use an accumulator, then the similar performance is also available, and this is not for very large load, small load, and maybe for small stroke it will be suitable. Now, how it works? The balancing of a force or weight can be achieved by using hydraulic pistons driven by an accumulator, thus avoiding the use of counterweights with attendant dimensional and weight savings. Now, this system looks like this. Typical application is machine tools, hoist, I would say small hoist, not big hoist. Now, in that case, what we find, the pump is not shown, but there is one stopcock, not non-return valve, stopcock is there. This is just to show the schematic diagram. It can be replaced by non-return valve also. We find the relief valve is here from the accumulator side, and then it is connected to this side. Then how it operates, that either we can run the pump, but when the pump is not running, then this oil will prevent the load for falling. Okay. So, in many cases you will find that machine tools, particularly say let us consider the drill hole, drill head, it is coming down. When you just leave it, that means when it the downward pressure is off, then gradually it goes off. So, or we would like to maintain that positions. In that case, we can call it counterbalancing, and that can be done by an accumulator. Now, it can be used as a hydraulic line shock damper. Rapid valve closure can produce shock waves, water hammer, resulting in over pressurization of pipes, joints, valve, etc., and even it can damage the system. You see, this water hammer is it is name is water hammer because this is maybe first it observed with water flowing, water storage system, but it can be, it can happen in any liquid. And if we close the valve suddenly, what happens, the pressurized flow, but it is blocked, there will be very sharp rise of the pressure there, that will generate a wave inside the oil, and that wave propagates very rapidly and it oscillates, it generates a dynamic condition inside the storage, and that may even cause the bursting of the system, pipelines, etc. Now, let us see what happens. The use of a suitable accumulator can neutralize or significantly reduce the shock. Now, this is an water storage system, this is the pump from the reservoir and water is being pumped here. Then let us consider there is no accumulator, without accumulator, then suddenly if we close this valve, then what will happen, this water, this side will be disconnected and there will be an water hammer inside, and this will be large pulsation of this liquid. Now, if we use an accumulator, then when we close this one, then this shock will reduce, and it even if it is not 0, amplitude is not 0, but this will low amplitude. So, this can be controlled by using this one. Definitely there will be a vibration sort of things, or you can see this is acting as a damper. In case of damper, of course, there is a orifice and other system. In that case, it is nothing is there, oil is going in and it is giving pressure on the bladder if it is inside, or if the gas or pressure is air is there, it is just knocking that air or gas, and in that way the shock wave here is reduced. Okay. Now, typical application are water, fuel or oil distribution circuits, washing equipment, etc. Now, definitely as we have explained, for reduce the water hammer or shock there. So, definitely this such an accumulator can be used as a shock absorber also. Mechanical shocks in hydraulically driven equipment can be absorbed by accumulators. So, in this case what we have shown some sort of carriage, or this may be two wheels of a or some earth moving equipment. In that case, what we find that this axle is on a damper, this is damper, and in the damper there is another accumulator is fitted. But look into this, there is no pump, the oil is stored. So, there will be, we have to pre-charge the system, and then when any shock is coming over here, then the oil is going inside, and but this cannot be in here. So, while it is going back to the cylinder, then it is going through this path. Okay. So, it acts as a something you can say that hydraulic spring sort of things also. Okay. So, instead of mechanical spring, one accumulator or along with mechanical spring, accumulator and a damper will have better vibration reduction than without accumulator. So, here the typical applications are forklift trucks, mobile cranes, agriculture, civil engineering machinery, etc. But these are usually used for large system, not for the very small system. However, you may find that similar accumulator or very small accumulator also can be used for vibration isolations for small vehicles also. Now, I have just mentioned the hydraulic spring. In that case, again we will find that this can be used as an hydraulic spring. Now, the accumulator can be used with advantage as an alternative to mechanical spring. Okay. Instead of mechanical spring, we use some hydraulic spring. In that case, if you look into these operations, there is an accumulator fitted over this system, and in that case this acts as an hydraulic spring. Probably this is an say hammering machines or forging machines. In that case, we can use such hydraulic spring instead of mechanical spring. The thrust can be easily controlled to great accuracy over a wide range of pressures by oil pressure control without the need for springs or supports. This means, in case of mechanical spring, you cannot change the spring constant. Okay. Only say it can take certain amount load depending on the how much compression is possible up to the failure of course. In this case, you can change the stiffness of the spring constant, because you can increase the pressure of the system by regulating the pressure, and your accumulator is selected accordingly. Now, this is fluid separator and transfer barrier. This is another application of such an accumulator. In that case, what is there, and two sides of the system there are two different fluid, in between there is an accumulator. Fundamentally, the accumulator separates two fluids. In the case of hydraulic applications, say we can say nitrogen and oil. However, the accumulator can be used when pressure has to be transferred between two incompatible fluids, hence the name is transfer. Now, this is a very simple system it is shown. Suppose what we consider that in figure 9, simplified diagram for a fatigue test of a vessel S using water. In that case, what we can do, that we are testing fatigue testing of this cylinder, and here we are creating this pressure by the oil, but inside there is water and this is separated by an accumulator. So, we are creating pressure here through this accumulator bladder, the water inside is being pressurized, and by oscillating this one we are applying the fatigue load to this vessel. Okay. So, this is one application of this accumulator, which is called transfer. Then initial pressure pulse is generated by piston pump P, this is the piston pump P, using oil, and equal volume and pressure is transferred to the water in the vessel by the accumulator. Okay. Many similar applications are found in petrochemical industries. Now, another example of the transfer barrier is that in that case what we find that typical application of transfer between liquid and a gas, this is a nitrogen, by using an accumulator with additional gas bottles. Say we here as if two accumulators and oil is being pumped here. So, this oil can go this way, but when we open it then this will be pressurized and then this nitrogen in this case nitrogen cylinder that will be filled or equalized, something will be there. This is a very schematic applications of accumulator, but this is the transfer process. These are usually used in industries, say chemical industries and similar big industries. This application is especially convenient in those cases where the amount of liquid required is quite large compared to the small difference between the operating pressure. Okay. This is in these systems actually we need very large amount of oil with a very small pressure difference, and then this accumulator helps is doing to meeting such requirements. To reduce the total capacity, therefore, the number of accumulator requires, the volume of available gas is increased by connecting the accumulators to additional gas bottles. I see. So, we can add more bottles and by this we can reduce the number of accumulators. Now, this is another applications where we can use the accumulator. This is fluid separator, this is same transfer barrier, but this application is steering unit. What we find that this is the steering and this is an steering valve, and this is the accumulator. Okay. And we find that steering pump is here and steering pressure switch is here, manifold relief valve is here, steering hydraulic tank is there. Now, this is a circuit, it is not very clear, but in, out, left and right, that means there are this is some separate operation, left right motion and in and out motion. Okay. Now, these are two steering cylinders and double pressure relief valve is used here. Now, this actually if we think of the steering, then in that case normally what we do, suppose we are trying to turn the car or any vehicles, in that case we move this one, then there the steering system which is fitted to the wheel hub of the steering wheels, that is rotating the wheels to a position. Now, actual force is required much more than what the force we are applying. Then what happens in sometimes we suppose we are trying to negotiate these wheels, but we are turning this wheel, we have to turn more and more to get the required action at these wheels. Now, in that case if the accumulator is there, that will help further to move these wheels. So, this is not very it will not be very clear from looking into system, but this is just a system shown how it looks like. So, you will find usually these are not the ordinary car, these are usually off highway vehicles, where in the steering wheel you will find the huge load is required, you will find an accumulator is fitted to the system. Without this accumulator, this will also operate, but you in that case you we will find you have to not only give more effort, more load, as well as you have to give the more motion to get such action, so get steering action. Accumulator will reduce such additional effort. Many parameters are involved in selection of an accumulator. Now, we will think of how this accumulator can be selected. We have seen just the very preliminary applications of accumulator. Now, we will look into how it can be selected. Now, the most important parts are in the process of selection. First of all, we have to think of what will be the minimum working pressure P 1 and what is the maximum working pressure P 2. The value of P 2 must be lower or equal to the maximum authorized working pressure of the accumulator to be chosen for safety reasons. Now, in an accumulator, whether it is with the bladder or simple the gas and oil accumulation, first of all we have to look into the capacity of such an accumulator. That accumulator can store, say it can store at 10 megapascal, then maximum pressure of the system should be below 10 megapascal. We cannot regulate that. That means accumulator pressure, accumulator capacity is not regulated, it is always precharged. Okay. The value of P 1 is found in the ratio P 2 by P 0 is less than 4. Normally, that P 0 is the charge pressure, P 1, P 2 is the working pressure of the system, minimum and maximum. P 1 is the minimum, P 2 is the maximum, where P 0 is the charge pressure, and usually P 2 by P 0 is less than 4. You see, look into this value. Now, as I told that it is less than, one may think that P 0 should be, that is charge pressure should be close to this one, but actually what it means that if you measure the pressure of the bladder after charging, you may find that pressure is some P 0 value. It will be less than the working pressure, but when this pressure will work on that bladder or the gas or whatever is there, that pressure will rise. Okay. And that pressure will rise, may rise a little above the P 2. It is design is in that way, which will give optimum efficiency and operating life for calculation of preloading pressure P 0. This is called preloading pressure P 0. Volume of liquid to be stored or utilized, that we have to consider. We are looking into the accumulators selections. First of all, we will look into the pressures in that way, then volume of liquid to be stored or utilized. That means, in that case what may be the shortfall of the volume in the process. Accordingly, we have to select the accumulator size. Sometimes we may find that one accumulator may not be sufficient, we have to go for one more accumulator. Okay. This information is required in addition to the maximum minimum pressure values for correct sizing the accumulator. Now, we have to look into the method and application. It is important to establish if the gas during operation is subjected to isothermal or adiabatic condition. Now, this is some thermal consideration we must do for accumulator selections. If compression or expansion is slow more than 3 minutes, so that the gas maintains approximately constant temperature, the condition is isothermal. Okay. Examples: pressure stabilization, volume compression, compensation, counterbalancing lubrication circuit. In that case, this is the isothermal condition. In other cases, energy accumulator, pulsation damper, shock wave damper, etc., owing to high speed transfer, heat interchange is negligible and therefore, the condition is adiabatic. Okay. As a guide, the adiabatic condition will exist when the compression or expansion period is less than 3 minutes. This guide means just thumb rule. If it is a 3 minutes, then less than 3 minutes, then you may consider the condition is adiabatic. Okay. So, these adiabatic or isothermal is important for the what the gas we are using inside the accumulator. Operating temperature. The operating temperature will determine the choice of materials for the bladder and steel cell, and will have also have an influence on the preloading pressures and consequently the accumulator volume. Type of liquid. This will determine the choice of accumulator body material, say what liquid we are using. Now, maximum required flow rate is another factor. The volume V0 and or the size of the connection is influenced by the speed of response. Okay. Location. It is important to know the eventual destination of the accumulator in order that the design can meet local design and test parameters. Okay. This is the position location selection of accumulator. Based on the foregoing, it is possible to choose a suitable accumulator for the specific application required. There are other factors also which are not discussed, but these are the major factors we have to consider. Now, we will look into the gas pre-charge pressure. The accurate choice of pre-charge pressure is fundamental in obtaining the optimum efficiency and maximum life from the accumulator and its components. Okay. So, we have to look into these pre-charge pressures which actually control the accumulator performance as well as the life of the components. The maximum storage or release of liquid is obtained theoretically when the gas pre-charge pressure P0 is as close as possible to the minimum working pressure. Now, for practical purposes, to give a safety margin and to avoid valve shut off operation, the value unless otherwise stated is P0 is equal to 0.9 P1. That means, if we know the system working minimum system working pressure is P1, then we can, as a thumb rule, we can select P0 will be 0.9 of that. That means, if P1 is 1 megapascal, then you can have the charge gas pressure without loading, no fluid is coming in, maybe 0.9 megapascal. Okay. The limit values of P0, that is P0 mean, is equal to 0.25 into P2. P2 is the maximum pressure, mind it, or P0 max is 0.9 of P1. So, P0 should be 0.25 into P2. At one point we have shown P2 P0 P2 by P0 is equal to 4. So, from there this relation and from this above relation we can have. So, looking into these working pressures we can have that what should be the P 0 which will be in between this and this. Okay. Then special values as follows are used for pulsation damper and shock absorber. The P 0 is 0.6 plus 0.75 of P m. I think this relations we should look into again, because this value is there without bracket. So, if it is an additional part, this is definitely the unit sensitive. So, we have to look into this relation is whether it is correct or not, or it is simply P 0 is equal to 0.8 into P 1 pulsation damper and shock absorber. Where P m average working pressure with free flow. Okay. Now, this free flow means that when there is no restriction over the flow from the accumulator. For hydraulic line shock damper, it is again taken P 0 is equal to 0.6 plus 0.9 P m. Again it is the unit sensitive. So, we have to look into this. Where P m average working pressure with free flow, the same, but these two relations are different for two applications. For accumulator plus additional gas bottles, it is 0.95 into 0.97 P 1, where P 0 is valid for maximum operating temperature required by the user. Checking of preloading of accumulator takes place generally at a different temperature to the operational one, so that the value P 0 at the checking temperature becomes P 0 some critical value P 0 into theta c plus 273 and theta 2 plus 273. Okay. This must be temperature in Celsius. Precharge pressure of accumulators directly supplied from the factory is referred to a temperature of 20 degree centigrade. Okay. Now, this lecture will be continued further. We shall continue over the accumulator selections, and then we solve a problem also, and we will learn more about the accumulator. Now, the reference for this one is a very old a tutorial note in a fluid power. It is not journal, you can say this magazine. It was in 1992, when this accumulator was still in development stage, or it was finding its application, and then this topic was found very interesting. So, this is from that topic, but next time we will also consult some book. Okay, thank you for listening.